So another year, another round of smartphone SoC launches. And I'm here with this, the Snapdragon 8 Gen 2. Video sponsored by Qualcomm. We're going to go through not only the specifications of this processor, but the base industry standard benchmarks on all of its cores. So if you didn't see the announcement, Qualcomm has announced its Snapdragon 8 Gen 2 processor. This is what's going to be in all of the flagships, most of the flagships coming next year. Qualcomm has that grip on the market. Now, it's an update to the Snapdragon 8 Gen 1. Here I have the Honor Magic 4 Pro, and this was a very successful SoC. It went into dozens, almost 100 devices. However, mid-year, we got the 8 Plus Gen 1, which is a move from a Samsung manufacturing to a TSMC manufacturing. And now we have this, the Snapdragon 8 Gen 2, again on TSMC manufacturing. Qualcomm saying officially that it's TSMC 4 nanometer, and inside the core is a bunch of extra new features for this generation. So those of you who haven't seen my previous videos on Qualcomm's reference devices before, you're probably wondering, what the heck is a Qualcomm reference device, or QRD? You'll see it in the graphs listed as QRD. So what Qualcomm does is they produce a unit which is basically similar to what an OEM vendor may launch as their flagship smartphone. I love these. The fact that we're able to get hold of them and test them well in advance of products coming to market next year is a good thing. And I really think that the other competitors in the market should do something similar. The two devices shown in this image are the Qualcomm reference device containing the new Snapdragon 8 Gen 2 SoC, and the other is the Honor Magic 4 Pro. Let's go through the specifications for each and what Qualcomm is doing new on the latest generation. Starting with the core count. In recent years, the prevalence of the 1+3+4 model means that we're very much familiar with how a modern smartphone CPU is configured. The Snapdragon 8 Gen 2, however, takes it a different route. Officially, this is a 1+4+3 design, with Qualcomm increasing the number of mid-cores by 1 and reducing the efficiency cores by 1. But the configuration is actually more subtle than that. Those 4 mid-cores are actually 2 groups of 2. This means at the high end we have a new Cortex-X3 core, giving higher raw performance per clock and running at 3.19 GHz. The mid-cores are split into 2 A715 cores at 2.8 GHz and 2 A710 cores at 2.8 GHz. We'll come to why in a second. For the efficiency cores, we have 3 Cortex-A510 cores at 2.0 GHz. We've got data to show the performance difference between the A710 and A715, however, for most applications it will simply act as one big block of 4 cores. Regarding the wider market, we can contrast the configuration to Mediatek's Dimensity 9200, which is also competing in this same price range. Mediatek has stuck with the usual 1+3+4 core configuration, but is now 64-bit only, having Cortex-A715 cores for the mid-range. If we go back to the Snapdragon 8 comparison, then Qualcomm is increasing the system cache from 4 MB to 8 MB, while leaving the L3 caches the same at 6 MB. This is to help balance the faster memory, as the Snapdragon 8 Gen 2 now supports LPDDR5X 4200 compared to 3200 in the previous generation. For graphics, Qualcomm is supporting Vulkan 1.3 and hardware-accelerated ray tracing. This is an update over the Snapdragon 8 Gen 1 family, and Qualcomm is claiming a 25% faster GPU at the same power, or a 25% power saving at the same performance. In detail, Qualcomm said that they've upped the ALU count, and texel and pixel fill rates have also increased. Our benchmarks will show that it can even get better than this, so stay tuned for that. With the new hardware-accelerated ray tracing, as with all ray tracing hardware, it will take time to get software on the market to support it, but Qualcomm states that they can apply ray tracing in some scenes for as little as 5 milliwatts of power, although it wasn't stated at what frame rate or resolution. At full bore, Qualcomm quoted support for 77 billion interactions per second for the ray tracing, which means that rays can interact 77 billion times with objects in the scene. If we consider that a full 4K Ultra HD display, running at 60 frames per second, processes a total of 500 million pixels per second, this means that the Adreno GPU can perform 154 ray interactions per pixel on a 4K Ultra HD display. One of the big updates for this new chip is the AI engine, which Qualcomm calls its Hexagon processor. They've done a number of significant improvements. It still supports scalar, vector, and tensor AI instructions, but we now have double the tensor performance, which means a lot for high-performance matrix operations. The Hexagon AI engine, also for the first time, is now on its own power rail internally, such that the SoC can reduce frequency and voltage when it's not in use, or ramp it up when it needs to. In previous SoCs, it ran at the same voltage as the processing cores, and that usually means a lot of static power when idle, so this will help in battery life, performance, and efficiency. The Hexagon also supports micro-tile inferencing, which is a software and hardware solution to speed up transformer networks, the new important element of machine learning. Combining this with the new support for integer 4-bit operations, or int4, which is a quantized number format that helps with performance, Qualcomm is stating that overall it expects a 4.35x uplift, or up to 4.35x uplift in AI performance, or about 60% performance per watt. A side note here on that integer 4 support, it is relatively new, so Qualcomm is working with its OEMs to have it directly integrated into their software. It will take time to propagate for now, but it is there. There's also now double the AI performance in the Qualcomm Sensing Hub, with 50% more local memory, allowing for new features such as an always sensing camera. This means that OEMs can implement a privacy mode with a secondary camera, where it detects if there's a second face looking at your smartphone over your shoulder and can automatically disable notifications. One other element here on the Hexagon is the new Hexagon Direct Link, which provides direct cache access between the Spectra image signal processor and the Hexagon AI engine. This means that normally when data comes in from the image signal processor, it would have to filter into the system cache or DRAM before going to the AI engine, which burns power. With this new Direct Link DMA feature, which Qualcomm is calling its Cognitive ISP, the SoC can perform faster machine learning on images and video. This will enable certain features, such as real-time segmentation filters, where it can provide different camera styles to different elements in the frame while already in the viewfinder, rather than solely doing it in post-processing. There are also engines to help accelerate low-light performance, bokeh performance, and enhanced video capture. The image signal processor still supports 200 megapixel cameras, or 108 megapixel with zero shutter lag, or 3 36 megapixel shots at once, also with zero shutter lag. One of the big features this generation is that Qualcomm has finally added AV1 video decode support into the system. As AV1 content is becoming more prevalent for content delivery networks, this should reduce the strain on bandwidth. When it comes to bandwidth, there are some updates here too. The Snapdragon 8 Gen 2 will contain Qualcomm's Fast Connect 7800 Wi-Fi solution, which is Wi-Fi 7 ready. It will still be backwards compatible with Wi-Fi 6 and Wi-Fi 6E, and even though the standards for Wi-Fi 7 aren't even finalized yet, Qualcomm feels confident that because they're involved in defining those standards, they will have hardware that will support it and any access points that comes to the market as Wi-Fi 7. The Qualcomm solution here supports some of the Wi-Fi 7 optional features as well, such as 320 MHz channels and high band simultaneous multilink. There's also Bluetooth 5.3 in there as well, upgraded from Bluetooth 5.2. For the modem, inside is the new X75G modem, which supports millimeter wave, sub-6, and 5G dual SIM dual active, such that both SIMs can be using the modem at the same time. Previously, it was time multiplexed. The X70 supports 4-way carrier aggregation on the downlink, and Qualcomm states that this is the first 5G modem RF solution to feature a built-in AI accelerator to help with signal integrity, security, and quality. And a final point that most people might miss, the Snapdragon 8 Gen 2 also supports UFS 4.0 storage for that faster onboard access. Now, I should stress that this video, all testing was done independently. Even though this is a video sponsored by Qualcomm, they gave me the device and they said, run what you like on it. Just let us see some of the benchmarks first. And that's what I did. Nothing has been out of the ordinary. And the reason why they do this is because I'm one of only a few people who actually run these industry tests. We're going to go into some spec. We've got some performance per watt numbers. So the first graph I'm going to show here is the SPEC into 2017 data. This is a geomean of the integer test in the SPEC 2017 suite, and we have the new cores listed in red. Qualcomm's other cores and historic cores are listed in gold/orange, while Samsung are in blue, Apple in grey, and Mediatek and others are in yellow. Various x86 chips will either be in purple or listed on the right-hand margin. For this graph, we are plotting performance on the y-axis and energy on the x-axis, with the size of the data point being the average power consumption. This means that the best data points are at the top, which means more performance, and to the left, which means less energy consumed, with the smallest circle. The top red circle here is a Snapdragon 8 Gen 2 Cortex-X3 core, which scores 5.73 points for around 8,000 joules of energy. Compared to the Flagship X2 from the year before, this is 19% more performance for 18% less power, or a 43% increase in performance per watt year to year. The 8 Plus mid-year refresh is about halfway in power, but the big gain is on the performance side. If we look down to the mid-range cores, we're now at a stage where Qualcomm's mid-range cores are as powerful as the Snapdragon 865 performance cores from 2019, but consume almost 20% less power. These cores, at the top of the voltage frequency curve, are 2/3 of the performance of the Cortex-X3 at only 2/3 of the power. If we just focus on these two results for a second, the difference between the A715 and the A710, the performance between them is almost equal, within 1%, while the new A715 cores were actually 6% lower in power. Then we have the low-end Cortex A510 cores. We are certainly above the performance of the old A55 cores that used to dominate this space. We're around 70% higher performance. Compared to some of the older Samsung A55 cores, this extra performance is also at half the power as well. But the Cortex A510s aren't really pushing the boundary. Small in-order cores are seemingly okay when you need to make up the numbers, but it's hard not to notice Apple's efficiency cores here are double the performance of the A510 at half the power. Those Apple cores are actually out-of-order cores and bigger, but it's the power efficiency that's really hard not to notice. As we move on to the next set of results, floating point SPEC, we start again at the top, and the Prime X3 core is again top of the non-Apple results, with better performance and lower power than both the chips from last year. When it comes to the mid-cores, we see more of a separation here between the A715 and the A710, with the A715 offering high single-digit performance gains for the cost of around 10% energy. That A715 is almost the same performance as the Cortex-X1 in the Snapdragon 888, but over 1/3 less energy consumed. At the low end, the grouping between the A55 cores at the bottom is relatively small, but those Apple cores are again better. I'm waiting to get hold of Mediatek's Dimensity 9000 series devices to see where they fall on this graph as well. If we move on to the graphics results, this one's a bit of a doozy. When I tested the Snapdragon 8 Plus Gen 1 mid-year, it was a showcase of similar performance for really impressive power gains. With the new Snapdragon 8 Gen 2, we're at the same power as that chip, but the graphics performance gets a large jump. In GeekBench Aztec at 1440p, this translates to 25% more performance at the same power. I even had to extend the chart vertically to support this. When testing the reference device, it's worth noting that the average power in this test is around 8 watts. At its peak, I saw the power spike to above 10 watts, but it spent most of its time around that 8 watt number. This is certainly a lot better than those 10 watt plus experiences average that we used to have. If we reduce the resolution down to 1080p for Aztec, then we see another 25% bump in performance compared to last year's Snapdragon chips to the new 8 Gen 2. The power is still in the same ballpark as the mid-generation refresh, slightly higher but within reason. Because we're testing these at peak power and performance and not fixed power, it's hard to say where the power performance graph goes, but in this instance, I find it safe to say that the new Snapdragon 8 Gen 2 should be better regardless of the power at any reasonable frame rate. If we move to the slightly older benchmark Manhattan, we see similar performance differences to the GeekBench tests. Now we're getting above 200 frames per second. If you attach a mouse and keyboard, I'd say we're almost ready for high-speed Twitch gaming. Moving to a more familiar system-level benchmark, GeekBench 5 is usually a good proxy for raw performance. For these data points, for the hardware I don't have access to, I've taken reasonable data points from the GeekBench 5 database. To interpret this graph, the horizontal axis is single-threaded performance, while the vertical axis is multi-threaded score. I've also added a few x86 CPUs in purple. I had to choose ones with multi-threaded scores around the smartphone chips, because desktop core counts are a bit crazy and would distort the graph. This is why if you recognize the models used, they're slightly older, hence the lower single-threaded scores. However, in this graph, we see that the Snapdragon 8 Gen 2 causes a sizable bump in both single-thread and multi-thread performance over the previous generations. We're scoring almost 1500 in single-threaded and over 5000 in multi-threaded workloads. If we plot the orange circles from Snapdragon 865 to today, it's becoming a semi-exponential. To be honest, I wasn't sure what to expect from GeekBench 5 this generation compared to last. A jump in single-threaded performance from the X2 to the X3, sure, but the shift to 4 middle cores rather than 3 seems to have done the job with multi-threaded. I can only imagine that someone is seeing this and thinking how they can move one more of those efficiency cores to the mid-range, or perhaps even a mid-range core up to the prime core. The final graph here is PCMark, and rather than give the subtest data for several more graphs, this is just the final performance geomean number. PCMark is often a good proxy for general performance here, and we see that while the mid-gen refresh last year was a slight bump, generation on generation moves the needle a bit more, and we're well above the Snapdragon 888 days. There are a number of Snapdragon 888 data points here simply to showcase that we're testing reference devices today, and when it comes to the retail units, there is often a variation between the designs. I do have some non-Qualcomm devices incoming for extra data points, and those will be interesting. So far, most of the comparisons that I've made and most of the comparisons you'll see from Qualcomm are comparing the Snapdragon 8 Gen 2 to the previous generation flagship, the Snapdragon 8 Gen 1. Now these chips are launched at the beginning of their product cycles. They're the ones that all go into most OEM devices you'll see on the market. Now Qualcomm obviously launched mid-generation, the Snapdragon 8 Plus Gen 1. Normally with these mid-generation refreshes, there are a slight frequency bump, we get maybe a little bit of increase in performance per watt, and it goes into a few devices, but it's not the mainstay of the generation. However, last generation, of course, the 8 Plus Gen 1 moved from Samsung to TSMC, and as you may remember in the video I did then, we saw impressive performance per watt gains. So why aren't we comparing the 8 Plus Gen 1 to the 8 Gen 2 here? The reason is more because of that volume, right? The top of the stack, the top stack initial flagship product is the one that goes into most smartphones. We'll see this in dozens, if not high double digits, low triple digits, premium tier smartphones and other devices as well. The mid-gen refresh will probably go into a handful, and while that provides a good performance gain, it's still not the mainstay of the generation. And that's just the nature of what makes sense for where these chips are going in volume. This is why you'll see a lot of the numbers increased in performance and performance per watt may sound very similar to the 8 Plus Gen 1. But beyond that, we're also getting that increase in CPU, GPU, the AI hexagon processor, the Wi-Fi, the baseband. There's a lot more that goes into this chip that obviously those comparisons will show. Now, people will say, okay, Ian, you've got Qualcomm's main competitor Mediatek. They just launched Dimensity 9200, which has roughly the same core configuration, and it's going to compete in the same space. What are the differences between the two? Now, Qualcomm is ahead in the fact they actually give us devices to test. Mediatek don't do that yet when they're announcing a new SoC, so we haven't tested the 9200. In terms of comparison points in the specifications, the 9200 and the 8 Gen 2 share a very similar core configuration. Qualcomm's are slightly higher clocked. But in terms of the GPU, Qualcomm has a very custom Adreno design, whereas the competition is using just the stock cores from ARM. Then you've got the AI processor. Both are trying to lead the way in terms of this sort of CGRA, reduced precision architectures, but Qualcomm's is at least a step ahead of that. Then you've also got security and then Wi-Fi 7, both companies have Wi-Fi 7, and then 5G modem as well. Qualcomm's usually at the forefront of that just because they're involved a lot more deeply in the standards than the competition are. But this is kind of what the future has to be for these premium tier smartphones and the SoCs that go inside them. Qualcomm's whole thing here is that they want to be able to provide a unique element, that unique plus factor on every part of the SoC. We've got it in graphics, we've got it in AI, we've got it in the 5G modem. This market is all about providing those additional benefits. Now on the software side as well, just to highlight here, Qualcomm has 6 pillars of its software. We have Snapdragon Sound, Snapdragon Sight, Snapdragon Elite Gaming, just to name a few. This is the results of Qualcomm putting years of R&D money into the software side of its platform. What we've got with the competition is that's their first or second generation flagship device, and they're on that way, but not to the same level that Qualcomm is right now. So we're going to see OEMs. I did have a question while I was here, even from the other press, saying, why would people pick Qualcomm? Surely the competition may be cheaper. And the whole thing here is that what does the chip bring to the table? Now, both companies obviously work with their OEM partners to try and build the best designs, but it's additional what you get on that. Do you get that unique factor, the unique selling point? Do you get the software stack? Do you get the support? And also, Qualcomm's the incumbent here. They have most of the market in the premium tier. Usually when we see a new competitor, it takes a few years to get going, because not only do they need a roadmap, they need to convince the OEMs that they can play in that space. So Qualcomm still has a very strong hold on it, and they've got very competitive products. I mean, testing this, I expected, good improvements in the CPU with the new Cortex-X3, the Cortex-A750. We might have some slight bumps. TSMC 4nm, I was expecting, maybe a little bit of performance per watt advantage. But then if we look at the GPU, we're seeing very considerable increases in GPU performance and performance per watt, which I wasn't necessarily expecting. What we're seeing here is that the 8 Gen 2 is actually going to be a really, really good gaming phone. Add in on top of that features like Vulkan 1.3 and hardware accelerated ray tracing. They'll be a bit slow to get off the ground. Part of what Qualcomm has to do here is work with software vendors in order to enable those features. Same with Int4 inferencing on the Hexagon DSP. While it's great that these companies are now supporting lower precision quantization for the AI inferencing, the competition is doing something similar as well, is that actually needs to be enabled at the application level. It's not transparent to the application, to the OS quite yet. And AI is a little bit different than graphics. Normally, when you develop a game, you can either optimize it for a platform, or even if you don't specifically optimize it for a given platform, the idea is that at least it runs. With AI, it's a bit different because you've got accuracy to think about. In gaming, you can throw away, if you've got a 16-bit calculation on color, or 10-bit or an 8-bit even, perhaps you can throw away the final bit, and that also helps processing. With AI, you need the accuracy, so maybe it's not as straightforward. Overall, I'm expecting a good showing from Qualcomm this year. The chip is better than last year in terms of performance per watt, and it's got a bunch of features moving us into that next generation of smartphone. Let's get one into test.